Do you have the time to listen to me whine about nothing and everything all at once? I am one of those melodramatic fools, neurotic to the bone, no doubt about it. Sometimes I give myself the creeps.
Today I will present our laboratory practical on the noise dosimeter and sound level meter SLM. Noise pollution is a significant occupational and environmental hazard that can affect health and workplace performance. Prolonged exposure to a high noise level may lead to hearing loss, stress, fatigue, communication problems, and reduced productivity. Therefore, noise assessment is important to ensure safe exposure level and compliance with occupational safety standards. In this practical, we use two instruments. The noise dosimeter measures an individual personal noise exposure during activities, while the sound level meter measures the ambient noise at a fixed location. Both assess noise but provide different types of data. The objective of this practical were to determine personal noise exposure using the noise dosimeter, measure ambient laboratory noise using the SLM, and understand the proper use of both instruments.
Hello everyone, so today I will demonstrate how to use a noise dosimeter and explain its primary function. First, press and hold the power button on the left side of the dosimeter for a few seconds until the screen lights up. After that, we need to calibrate the dosimeter to ensure accurate readings. On the menu, tap choose calibration and then choose calibrate. And then attach the acoustic calibrator securely to the microphone. Next, wait for the calibrator to calibrate the noise dosimeter. After the calibration is complete, remove the calibrator carefully. Now, attach the dosimeter to the worker body using the clip provided. Place the microphone near the worker ears, usually on the shoulder area, approximately 1 handspan or 50 to 20 centimeters from the ear. Because the position measures the actual noise exposure received by the worker, ensure the microphone is not covered or blocked by clothing. After that, switch on the dosimeter and press the start button to begin the measurement. So now, let's follow Najwa as she walks around the workplace carrying the noise dosimeter during her normal daily activities. The dosimeter will continuously record her noise exposure level throughout the monitoring session. As Najwa moves from one area to another, the noise level may change depending on the surrounding environment and equipment being used. At some point, she enters an area with a higher noise level caused by operating machinery. The dosimeter automatically detects and records the increase in noise exposure received by the worker in that area. Once the measurement is complete, start the recording and check the display result. The dosimeter will show data such as exposure time, average noise level, and noise dose percentage.
I start by switching on the sound level meter. I wait for the device to fully power up and then it takes a few seconds before it's ready to use.
A few moments later.
Next, I press the tools and setting button and select the calibrate option. Then I select the calibration setting, which is LC Cal 200, 114 dB and 250 Hz as required for the calibration process. After that, I attach the acoustic calibrator, which is a LD Cal 200 sound level calibrator, onto the microphone of the sound level meter. This ensures a seal fit for accurate calibration. The device then starts the calibration process. Once completed, the measure different display on the screen. Then I press yes to save the calibration result. After calibration, I start the measurement process. Before that, I attach the foam windscreen on the microphone to reduce noise interference. Then I place the sound level meter at the distance of 1 meter from the noise source. I start the measurement and wait for 1 minute. After 1 minute, I record the result shown on the screen. I press run button on the sound level meter. Then I place the meter at a distance of 2 meters from the noise source. I'll let the measurement run for 1 minute. After 1 minute, I record the result shown on the screen. So this is the last measurement. I press the run button on the sound level meter. Then I place the meter at the distance of 3 meters from the noise source. I let the measurement run for 1 minute. After 1 minute, I record the result shown on the screen.
Hi, I'm Iman as well. So I will continue with result and discussion for dosimeter and sound level meter. So let's start with a dosimeter. First, I'll present the result obtained from the dosimeter. The dosimeter was used to measure personal noise exposure over a period of about 30 minutes. From the measurement, the average noise level recorded was 55.1 decibel. Meanwhile, the noise dose record was 0.01%. This result showed that the noise level during the monitoring period was quite low. The average noise level of 55.1 decibel indicate that the surrounding environment was relatively quiet and not noisy. This value is still below the common occupational exposure limit of 85 decibel, which is usually considered the safe limit for an 8-hour working period. For the noise dose, 0.01% is extremely small. This means that the exposure level is almost negligible compared to the allowed daily noise limit. So overall, both results show that the area is safe in terms of a noise exposure during the time of measurement. However, this result only represents a short sampling duration. If the measurement is done for a longer time or in a busier environment, the result may be different. Next, I'll present the result obtained using the sound level meter. The measurements were taken at 3 different distances from the noise source, which are 1 meter, 2 meter, and also 3 meter. Each measurement was conducted for approximately 1 minute, and the average sound level value was used for comparison. At 1 meter, the sound level was the highest with a value of 57.3 decibel. This is because the sound source is very close, so the intensity of the sound is this strong. When the distance was increased to a 2 meter, the sound level dropped slightly to the 55.9 decibel. This shows that the sound energy has started to spread out as it moved further away from the source. At 3 meter, the sound level further decreased to the 54.7 decibel, which are the lowest value recorded among the 3 districts. Overall, this result clearly shows a decreasing pattern in sound level as the distance increases. This happens because sound waves lose energy as they travel through air, causing the intensity to reduce gradually. So, in the general, the findings are consistent with the basic principle of sound propagation, where the farther you can from the source, the lower sound level you will experience.